Welcome to Stoichiometry tutorial number 7. This tutorial is for extra practice and it will be the last tutorial to hopefully help you be successful on your stoichiometry test that is coming up this week. And so you'll need the usual supplies for this tutorial, and this tutorial will only cover one problem. It is a bit more of an advanced problem, multi-step, and it's a bit different than what we've done previously. You might see some problems like this on the homework on pages 8 through 12. So if you pay close attention here, hopefully it'll help you successfully complete that homework. Well, let's take a look at this problem. It's a long problem as it is. It tells us phosphate baking powder is a mixture of starch, sodium hydrogen carbonate, and calcium dihydrogen phosphate. When mixed with water, phosphate baking powder releases carbon dioxide gas, causing a dough or batter to bubble and rise. So this is what we often see in baking. And so thankfully we're given this equation and it is balanced, and so we just need to see what the problem is asking then. But a few things to note first, just by looking at this problem, it tells us it releases the carbon dioxide gas. That's what causes it to rise. And so that's one of the things we'll be most likely be looking at. But let's take a look. Here it tells us that 0.750 liters of carbon dioxide is needed for one cake to rise up properly, and each kilogram of baking powder contains 168 grams of sodium hydrogen carbonate. How many grams of baking powder must be used to make exactly 3 cakes? The density of carbon dioxide gas at baking conditions is 1.20 grams per liter. So we are given that we want to make 3 cakes, and we know that 0.750 liters of carbon dioxide are needed per cake. And that's a little hard to see. Let me switch colors. .750 liters of carbon dioxide per cake. There you go. Now you can see that better. And each kilogram of baking powder contains, here it tells us, 168 grams of sodium hydrogen carbonate. And so to begin this problem, let's start with our given unit of exactly 3 cakes. I'll try to explain why in a moment. So if we have 3 cakes, what we see is that we can use this value here as a conversion factor because it's 0.750 liters of carbon dioxide per cake, and then here you have 168 grams of sodium hydrogen carbonate per 1 kilogram of baking powder. So starting with that, we have 3 cakes, and we know we need 0.750 liters of carbon dioxide per 1 cake, but we're making 3. Then the next thing we have to look at here is that it gives us the density of carbon dioxide gas at baking conditions. And so we're not using the 22.4 moles per liter. That's not a density. Instead, we're going to use the density that ties grams and liters together. So it's given to us, and that's why it's very important you pay close attention to what is given. So you have 1.20 grams of carbon dioxide per 1 liter of carbon dioxide. Alright, now that we are in grams of carbon dioxide, we need to convert back to moles of carbon dioxide, and so we're going to use molar mass, and that has been calculated. 44.009 grams of carbon dioxide is equal to 1 mole of carbon dioxide. Now we need to make the jump from moles of carbon dioxide to moles of sodium hydrogen carbonate. So we know that anytime we go from moles of one compound to moles of the other, we must use the mole ratio, and the mole ratio is going to come from the balance equation. You have 2 moles of carbon dioxide to every 2 moles of sodium hydrogen carbonate. Now that we are successfully in moles of sodium hydrogen carbonate, we're going to use its molar mass to get to grams. So its molar mass, I have calculated that out as well. 1 mole of the sodium hydrogen carbonate is equal to 84.006 grams of the sodium hydrogen carbonate. But it's asking how many grams of this baking powder must be used, and so we're not stopping at the grams of sodium hydrogen carbonate, but we're going to use this other conversion factor. We know that there's 168 grams of sodium hydrogen carbonate per 1 kilogram of baking powder. So for this last step, we're going to use the conversion factor that's given to us here. Each kilogram of baking powder contains 168 grams of sodium hydrogen carbonate. So we know that 168 grams of sodium hydrogen carbonate contains 1 kilogram, or is in 1 kilogram of baking powder. And since we want to know how many grams of baking powder we have, we'll get this value and then we need to convert it to grams. So 1 kilogram is equal to 1,000 grams, and this should give you an answer of 31.7 grams of baking powder. That is how many grams you would need for 3 cakes, exactly 3 cakes, 31.7 grams of baking powder. Sorry, oh no, I can't draw a straight line on this thing. So let's take a look back at our work right quick. Remember this value here, this is given to us as a conversion factor. So conversion factor from the problem right here. 0.750 liters of carbon dioxide is needed for 1 cake. So 0.750 liters per 1 cake. This was also given to us as a conversion factor, 1.20 grams per liter. So we see that need for that right here to use the density instead of 22.4 moles per liter at STP, because this is at baking conditions, not at STP. And then we also see the need for this one. This is another conversion factor given to us in this problem, that each kilogram, 1 kilogram of baking powder contains 168 grams of the sodium hydrogen carbonate. And so this problem is truly made more difficult by the fact that you have to recognize those conversion factors. And so as you're working through the homework and going through pages 8 through 12, make sure if there are any needs for things like this to be recognized, that you write them out beforehand, like we did here, and hopefully that will help you in solving these problems. So that is the end of this tutorial. I hope that it has been helpful, and if you are watching it today on Sunday, I hope you have a happy Easter.